Greetings to all. I am Dr.A.Judith Jayarani, Assistant Professor of Physics, Bishop Eber College, Trichy. Today I am going to handle crystals and its structure. So before get into crystals, we should know what are all the things in the nature. Matters are divided into three groups. One is solid, second one is liquid, third one is gas. So the solids are subdivided into two major categories. One is crystalline nature, second one is amorphous nature. So these are all the types of solid crystalline. So crystalline solids are nothing but well ordered or repetitive arrangement of atoms. So here you can see the molecules are arranged in the repetitive molecules. So the example for this type of crystalline material is diamond. So unit cell it is nothing but the smallest repeating pattern in the pattern of molecules in the crystal. So this is the smallest unit in the crystal. So it has some symmetry. So these are all the examples for unit cell. First one is isometric, second one is hexagonal, next one is tetragonal, next one is trigonal, orthorhombic, monoclinic, triclinic. So these are all the types of unit cell which is present in the crystal. Next one is crystalline lattice. Crystalline lattice, it is nothing but the array of points representing the arrangement of particles in the dimensional space, especially in the three-dimensional space. It is called crystal lattice. So these are all the three type of crystal lattice. First one is one dimension, second one is two dimension, and third one is three dimension. First one is periodic dimension, that is periodic dimension in one direction. Second one is periodic dimension in two directions, and the third one is periodic dimension in three direction. Next one is we should know what is unit cell and the shape of the unit cell. Here we are taking the example as sodium chloride, that is NaCl. So these this is the location of ions in the NaCl crystal, that is sodium chloride crystal. So in NaCl, Na plus ions are located at the corners. So here you can see. So this is the location of the NaCl crystal. So NaCl, Na plus ions are located at the corners, that is there are 6 Na and Cl ions are around the crystal and vice versa. So it is the example for simple cubic structure crystal, and is the smaller than, that is the Na plus ion is smaller than Cl ion. Here you can see 1 plus, that is blue, it represents the Na plus ion, 1 minus, that is the green ball, it represents the Cl minus ion. So here you can see the Na atom, so it has 11 plus and 11 minus, and the net charge it is 11 plus and 10 minus. Here you can see it is all around the crystal of NaCl. So coordination number it is nothing but the number of ions which contact a unit cation is called coordination number. So in NaCl it has 6. So here you can see at the corners there are 4 Na plus, and at the center there is one Na plus, and in the middle of the bases there are 1 in each dimension, that is Cl minus. Here you can see all it is around in the Na plus ion. So number of NaCl in each unit. So there are 8 Cl ions at each corners in the cube, and each ion is shared between 8 unit cell. So each phase shares with 2 unit cell. So here you can see, so this Na plus is shared by these 2 Cl minus. So similarly all Na plus is shared by the Cl ions. So here you can see the calculation that how much of Cl is shared in each corners. So 8 at corners, so 8 by 8 in each corner, that is 1 is shared in each corner, and 6 at the face center, and 6 divided by 2, that is 3 is shared in the center. So the total number of total coordination number is 1 plus 3 is equal to 4. So there should be 4 coordination number in the NaCl crystal. So Na plus, so here you can see the violet represents the Na plus and Cl represents in the green. So 12 at the edge centers, so 12 should be divided into 4, that is there are 4 faces. So the total is 3, and one body center, that is at the center of the body or center of the crystal, and that is shared all around the crystal. So the total is 3 plus 1 should be equal to 6. So there should be 4 Na plus ion and 4 Cl minus ion. So the total number is 4 NaCl. So there are different types of packing arrangement in the unit cell. So these are all the arrangement. So first one is simple cubic, second one is body center, and the third one is phase center. And before get into the arrangement of atoms in the crystal, we should know the structure of the crystal. So the structure of the crystal can be defined. There is a sum of lattice and basis which forms the crystal structure. And lattice, it is nothing but an infinite periodic array of points in a space. So it is called lattice. So here you can see the arrangement of points which defines the lattice symmetry. So the lattice may be 1, 2 or 3 dimension. So here you can see the arrangement of lattice point in 3 dimension. Basis. Basis can be called as motif. So motif is also called basis. So a group of 1 or more atoms located in a particular way which respect to each other and associated with each point, that is known as basis. So here you can see the arrangement of basis, that is the group of atoms located in a particular way or particular arrangement, that is called motif or basis. So here you can see the crystal structure which is the combination of lattice and basis. So we can obtain the crystal structure by adding the lattice and basis. So we can say that when an atom or identical group of atoms is attached to every lattice point, so we can obtain the crystal structure. So crystal structure are classified into 2 major types. One is polycrystal, the second one is single crystal. Polycrystal, it is nothing but the type of crystal in a periodicity but not maintained throughout the body. So the structure is not maintained in the throughout the body, which is called polycrystal. Single crystal, it is nothing but the type of crystal which has the periodicity in a particular exact manner, that is maintained throughout the body. So the crystal structure is maintained, that is the arrangement of atoms arranged inside the crystal in a periodic manner. So that is called single crystal. So unit cell, it is nothing but the atom or group of atom forming by building the block of the smallest acceptable size of the whole volume of a crystal. It is defined as unit cell. So unit cell is very important to form a crystal structure. Without unit cell, we cannot define the crystal structure. So here you can see the lattice point located in the unit cell. So as a whole, the array of the lattice point form the unit crystal. So every unit crystal, that is by adding the unit crystal, we can define the structure of the crystal. So here you can see unit cell in the 3 dimension. So there are unit cell in 2 dimension, but here we are seeing the unit cell in 3 dimension. So which explains the crystal structure in a periodic manner. So by stacking identical unit cell, the entire lattice can be constructed. So here you can see the unit cell, that is the entire lattice in the unit cell can form the exact crystal structure. So the lattice point are located in the corners of the unit cell, and in the same case, some cases at the faces or at the center of the unit cell, that is called face center and body center. So in a simple cubic structure, the unit cell is very important. So it is at the corner of the lattice point. So these are all the types, three types of cubic cell. So in a cubic cell, there are arrangement of atoms at the corners, that is called simple cubic, and there is a arrangement of atoms at the corners as well as at the body, at the center of the body, that is called body center cubic, and there are arrangement of atom at the corners as well as at the face, at the center of the face. So center of the each faces. So there are 4 faces in the simple cubic. So the at the center there should be a atom. So that is called face center cubic. So this is the arrangement of atoms in the simple cubic cell. So here you can see there are atoms at the corners which forms the simple cubic. So the total number of atoms per simple cubic cell, it is 8 into 1 by 8. So one atom is shared in each corner, that is in 8 corners. So there are 8 corners in the simple cubic. So one atom is shared in each corner. So the to represent that we are multiplying 8 into 1 by 8. So the one atom is shared in each corner. So next one is body center cubic. So here you can see there are atoms at the corners, and there will be a atom at the center of the body. So at the center, to represent the center of the body, we are adding one atom along with the simple cubic structure. So to represent that, the total number of atoms per body center cubic unit cell is 8 into 1 by 8 plus 1. So the total number of atoms is 2. So the next one is face center cubic. So there are 6 faces. So see, we are adding that with the BCC. So along with the BCC, so along with the simple cubic structure, we are adding atoms in each faces. So to represent that, there are atoms shared by 8 unit cell. So total number of atoms per face center cubic unit cell is 8 into 1 by 8 plus 6 into 1 by 2. The total number of atoms is 4. So these are all the 7 unique arrangement of crystal system which fill in 3-dimensional space. So simple cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, hexagonal. So these are all the 7 system of in the crystal. So in the simple cubic, all the 3 faces are equal. So A is equal to B is equal to C, and the angle alpha, beta, gamma should be equal to 90 degree, which is formed by the 3 faces. And here in the tetragonal case, B is not is equal to C. So the 3 faces are not equal. So here the angle are same, alpha, beta, gamma are same. So that is 90 degree. In orthorhombic structure, the 3 faces are not equal. So A is not equal to B, is not is equal to C, and the angle are same. So the alpha, beta, gamma, the 3 angle in the 3 faces are same. So it is 90 degree. And if you take the rhombohedral, the A is equal to B is equal to C. So that the 3 faces are equal, and alpha should be equal to beta and should not be equal, that is gamma should not be equal to 90 degree. So alpha and beta is equal to 90 degree, and which should not be equal by gamma, that is gamma is not is equal to 90 degree. And if you take the monoclinic system, the faces, 3 faces are not equal. So we are representing A is not equal to B and B is not is equal to C, and the angle alpha and gamma should be 90 degree and beta is not is equal to 90 degree. Whereas in the case of triclinic, So A is not is equal to B, B is not is equal to C. So the three faces are not equal, and the degrees, that is the angle, is not also not equal to 90 degrees. So to represent that, that is alpha is not is equal to beta, beta is not is equal to gamma, it is not is equal to 90 degree. And if you take the hexagonal, A is equal to B and B is not is equal to C. And the angles between the faces, that is alpha is equal to beta, should be equal to 90 degree, and gamma is equal to 120 degree. Thank you.